All right. Uh, okay, I'm not all the way to 15 minutes late. Almost 15 minutes late. But yeah, I should have just set the stream start time to 8:45. I was thinking about it, but then I'm like, nah, I can totally get it all ready uh in 15 minutes or whatever. But no, that didn't work. But yeah, I actually got I'm like pretty happy. I got a link cable that actually can plug directly into the wall at the same time, and like it's a little bit hard to see on camera unless like I bring it close, but it like glows. Looks super cool. Um, but yeah. So I'm actually like using Questlink, the thing that never works. And that was the one thing on stream that like just worked. Let's see, I'm actually going to like I gesture with hands. Must be able to see hands. There we go. Narrowly escaped a mention in Discord. Is I gonna get called out? Where stream? You scheduled stream. Where stream? Aha. I lied. There is no stream. But yeah. Oh, to like talk about here, let me situate this cable slightly. To talk about why there haven't been a ton of streams recently, it's actually been because I've been locked in working on other things. So I'll just quickly tease this right here. I think that's fine for me to do. It's not like too many people watch these streams. It's not like I'm like super leaking things I shouldn't leak. But yeah. My team, as you might be aware, won the VR Chat Game Jam, and our world had some cool things in it. So we're releasing a package of those soon. We're starting playtesting this week. Um, and yeah, the thing I'm most proud of, this was not part of the game jam, but look at this. This is a Unity event. Um, but toggle color. This is an Udon Sharp script. So if I go here, this is an Udon Sharp script, and the Unity event style-esque thing is able to directly call oh, not that one, is able to directly call functions in the Udon Sharp script. That is something not even Cyan Trigger can do, so I'm like super proud of that. It took a fair amount of reverse engineering of like just how Udon Sharp itself works. Actually, reverse engineering of basically all of it, because what these events do behind the scenes is it's a tiny compiler. Like we compile an entire Udon behavior that's actually hidden on this object to get that working. But the interface is like super clean, and now you have Unity events that can call both Udon Sharp events and actual Unity things. Like right here, it's directly setting the shared material property. So I'm kind of like showing off two different ways. Anyway, I'm gonna stop leaking stuff. I dubiously shouldn't. Um, but that's what I've been working on, and that will be released semi soon. But because I've been working on that and not, you know, this stuff as much, the reason I work on the other thing is because eventually. Wait a second. What is this? What is this crown thing you have here? Oh, it's just an XP thing. I was like, wait a second. This top fans 50 XP. Does YouTube give you XP now? What is this? Gamification of stream watching. Apparently YouTube thinks. Yeah, YouTube thinks I'm not cool enough without engagement mechanics. But yeah, so what are we doing over here on the BraneScript front? Well, seems to be gaining 25 XP every time you send a message. It would appear so, starting at your second message. Because you only have 75, but you've sent 4 messages. So I guess the mechanic kicks in after the second message. Interesting. I see no way that this system can be abused whatsoever. But yeah, so as you may be aware, getting back to the actual, like, what we're working on, is when I, like, went and sprinted to get the node graph working for AWE, I ended up deciding to make my own UI, which was that was a mistake, because I spent more time working on the UI than the actual thing, and then, like, I got the actual thing working in 3 hours after I got the UI working. And then after that point, I've still mostly been working on the UI and not making the actual language better. Or, well, not language, but scripting system. So what I've decided to do is, even though it is another rewrite, I'm completely ditching my custom UI system for the time being until we rewrite it in BraneScript. Because I know that I'm going to rewrite it at some point, so what's the point of me making a custom system if I know that I'm going to rewrite it? So we're going to just use a pre-existing library called eGUI snarl. So Rust has an IamGUI. Its most popular UI framework is eGUI, which is like IamGUI. And then this is a plugin for it that lets you do nodes. So we're going to use this, and then we're going to write a little bit of a auto layout system for this to auto positions the nodes, similar to what we were doing before. That's weird, this little, like, bounce here that's doing. And yeah, and then once we get all that working, and I feel like in 1 or 2 streams, we should be able to free and super chats. Interesting. Yeah. So that's the current plan. The only thing I'm concerned of is the way that my UI was working before was we had a node, or a node graph, and that node graph had a set of inputs, a set of outputs, and then nodes within the graph. Then we connect the inputs and the outputs, and it was very much a, like, defined positions for inputs and outputs. This node framework doesn't have a system for that. So we may have to, for the time being, have, like, input and output nodes that are just always exist in the graph, and we lock down their positions so they can't be moved. That is one thing we may have to do. But that's really the only thing I'm concerned of, is the whole, like, nesting graph structure I have right now. Aside from that, we're just going to go and figure out how to convert what we had before into this, and this should really only be 2 streams worth of work, and then we basically don't have to worry about UI from that point forward until we've made BraneScript good enough that we can rewrite the BraneScript editor in BraneScript, essentially. And that UI that we use will be the same UI in BraneScript, or in the BraneScript editor, and also for our engine. So at that point, we might just rewrite the Brane script editor in Brane engine rather than Brane script, which would be kind of crazy and actually kind of makes more sense. But yeah. So now I get to do the fun task of this library isn't quite as documented as I would like. They have an example, but they don't have like a Hello World example. They have a fully implemented example, and that doesn't help me much because, like, yeah, if I look at demo RS, how many lines of code are in this file? Yeah, they give me 1,000 line of code example, and this is what we have to work off of. And like, as like great as this library is, or it seems to be, that's a big example. Indeed, no hello world. So instead, I've constructed my own, which has no nodes. That's the first thing we're gonna have to figure out this stream is how to add nodes in there. Yeah. So you can see here. Actually, I did put a single node in. And I just hard-coded the all the data about this node as well. Yeah. So now I just need to decide how we actually want to structure this UI. I guess. What do? Yeah, I think first thing we're gonna do is I do want side panels like an inspector window over here. Can I make GUI windows? Wait, do I have to have an entire window, or not window, but library for this? No, I just wanted to look at. There we go. Do they have pictures? Yes. I don't know that I want to entirely layoutable right now. I want to keep it like simple. Okay, this might be closer to what we want. Okay, we're gonna go with this library for actually laying out our library, or yeah, or layout. Where is the documentation though? See, this is what you do. You give a hello world example that can fit on one screen. This is a lot better. Okay. So we're going to go to so we now have GUI tiles. Let's see what is required. Human soul? Dang it, I'm out of those right now. GUI titles behavior for pain? Oh, okay. Okay, so pain is all the different pains that we can have. And then this is how pains are drawn. Okay. Wait, there's substitutes? Dang it. Just realized there's no music. Wait, did I forget to... I've had it been going, but I just had it muted. Ah! Okay. Visible tiles with tree set visible. Cool. And now what I'm wondering is, see, if we do linear is what I'm interested in at the moment. It could be cool to have multiple grids shown at once. Yo. Yeah, I wasn't expecting that you'd be able to get away with that for free. The question I have is, how do I make it so you can't reorder things? Because I don't want these to be reorderable at the moment. Or maybe I just don't worry about it. Indeed, we do have a game dev in chat. Maybe they'll tell us how to make our thing actually work. Keep it as just game. This thing in question. So what we're working on right now is a node graph editor for the scripting system I'm working on for my game engine. We have a fully JIT compiled runtime that we already have working, but I was using a text-based scripting language before. But I found that I was spending way too much time doing like language grammar stuff, so I'm attempting to see if building it with UI instead of text will make it so I can focus more on making the scripting system actually, like, the runtime good. I'm hoping that this is faster than spending a ton of time on language features. To a point where it's actually usable, like accelerate it to a point where it's actually usable. We'll see. So far, I went down the rabbit hole of making my own custom UI, which, like, was working, but I was spending more time working on the UI than the actual scripting system. But yeah, so same problem as before, just now it was UI instead of text. I'm kind of split on the difficulty at the moment. I think with UI, it's with UI you don't have to worry about syntax sugar as much. With text-based languages, you have to worry about syntax sugar, and there's a lot of making the language work is a lot easier. Like, making a text-based scripting language like MVP is a lot easier than a UI MVP, in my opinion. Having a good text-based language is significantly more complicated than having a text-based language. We're gonna have this be a graph view. And then we're gonna have an inspector. Those are our two windows for the moment. And do they actually have state? They probably need a reference to the current project, because we do need to have editor state. Project. If we're doing arc, we might as well do mutex, because that means now this will be able to be shared between multiple threads. No, I don't want eGUI mutex. Why would I use my UI's threading system? On standard sync mutex. Yup. We are resting with this one. Though, to be fair, we should probably throw mutexes on the actual graphs themselves, or the data within the graph, instead of just having like a global lock. And like throw rewrite mutex on graph itself. Actually, rewrite mutex on project wouldn't hurt either. But I'm gonna worry about threading later. I need to stop myself from... Stop it. Stop it. Stop prematurely optimizing. We're just getting this working. Custom Rust ECS? Many such cases. Like, actually custom? Or just using Bevy? How much? Okay. Nice. Okay, so what do each of these have? We have a reference to project. And at some point we're gonna need a more generic, like, UI state struct. With undo support as well. I wanted to figure out threading and cache coherency benefits, but write more normal looking code. So I'm abusing coroutines now, and able to just iterate anywhere in the codebase and have it scheduling figured out automatically. That's the point of this entire scripting language that I'm working on here, is to do essentially just that. A ton of automatic threading, though. Like, I went really far off the deep end with it. It's a fully functional scripting system. And the reason why I went full functional is, one, you can design some like really cool LSP stuff if you go like super down the deep end of LSP, like super statically typed language. Potentially even like more static validation than Rust has, but not using lifetimes. I'm gonna use a different strategy than lifetimes. Compiler time reference counting of shared references. But with it being like a pure functional language, that means if any crashes, because it's supposed to be like super sandbox. This is for a for user-generated content, which means it needs to be perfectly secure. Now, crashes are usually a way that they're usually not handled the best. So the way that we handled crashes or that we're going to handle crashes with Brane script is, since it's a purely functional language, it just, if it crashes, there's no effect to state, so we can just move, like, continue on. So unless you're like halfway through a pipeline and like that pipeline causes like unrecoverable state in the game, the language itself can't cause the problem to crash. Maybe the logic that the scripting language influences can, but like the language itself cannot cause any memory corruption, which is my main goal there. So we have our graph view and inspector. Now we have those panes, so let's implement GUI tiles behave pane or this is for a certain structure. Interesting, I was never on the functional train. I would hear people talk about the benefits of functional programming, but only really go halfway and not gain any of the benefits of truly functional languages. Yeah, so the problem with, the main problem with functional languages is that by their very nature, when you say pure functional, that means a function doesn't have side effects. And the entire point of running a computer program is for them to have side effects. Like, drawing to UI is a side effect. Making audio is a side effect. And, like, basically anything you'd want a program to do is a side effect. So, you can have programs without any bugs if the programs don't do anything. That's essentially the philosophy of functional languages. Now, I have a workaround for this, and my workaround is the pipelines concept. So even before I was going to go purely functional, my idea was like, here is a block of purely synchronous code, and inside this code we can't do anything that requires locking a mutex, setting mutex data, any shared data can't be accessed within here. Instead, what we do is we have these barriers between the synchronous blocks of code right here, where this block can request multiple async operations at once. So you could say, hey, here's a handle to some async, like some shared state data. I would like the value of that data, or I would like to set this asynchronous variable. It doesn't happen in this block of code, but you can request for it to happen. And you have all these asynchronous things that it can go off and do, and then once all of those are done, we return to a synchronous block of code. So, what if we just said, hey, this block of code not only can't have any, like, multi-threading related side effects, but it can't have any side effects at all. And the only way it interacts with the greater program is by returning commands to the runtime. So you get all the inputs you requested, you do some transformations on that data to turn that into a list of commands for the runtime to do. And then after those list of commands are done, you can then continue and do other things. So this completely removes any thought about, like, what order things are happening, because you just, like, You just say, I would like all these things to happen. And you try to do as many async operations at once as you can, because you know all of them happen at once. So instead of like doing a wait in a for loop, like you sometimes see in React code, instead, you know, you'd collect a ton of promises and then send them all out to the runtime at once. So there's a lot of stuff like that you can do where this pattern kind of inherently pushes the programmer to be more efficient with the way that they write their code. So the way I see this is the limitations of functional programming and the limitations I'm putting on the way that you interact with the greater runtime will push people to, by default, write faster, like, threaded code. But also, I think it's going to make it easier to write code as well, because it removes, not being able to do things removes the overhead of needing to do things correctly. Like the mental overhead of like, okay, I need to remember this and this and this. No, you're just like, this is the only way I can do it, so this is the way that I do it. And you don't have to worry as much about the intricacies, because it does it for you. So this behavior... I'm wondering what a behavior is. Is a behavior just a render? Tiles. Traits behavior. Trait defining how the super tree and its panes should be shown. Oh, so you can say, is this closable? This is how we define the behavior of a certain set of panes. Okay. Yeah, I'm feeling like this is the sort of thing where once I have it working, I'm going to make an entire dedicated video visually showing how it works. Because I feel like there's a lot of abstract theory about why I think everything works together, but it took me basically years to like settle on this idea for how the language is going to work, and now I'm like, yes. And I keep calling it a language. Maybe runtime is a better term, scripting system, because we're like working on UI right now. It's not a language. Maybe visual language. Language is a not great term for this. It's not super descriptive. But yeah, this is going to be a lot easier to wrap your head around once I do get it working. I'm going to call this editor pane behavior. Proof of concept, but how I'm usually going to handle shared state is by simply just wrapping my shared state in async read-write locks that I have a custom task scheduler as well that supports this. That's similar to what I'm going to do behind the scenes too. How are you planning to handle on mutex locks for when something needs multiple mutexes at once? Because it sounds like you're going down a very similar route to what I'm doing. They spell this differently. Behavior versus behavioral. Behavior. Okay. Come on, give me the code actions back. I think we have to do the one editor restart before the LSP actually kicks in. Using futures and using join. The locking strategy won't cause deadlocks unless there's some logical error. Okay. Oh, is the rendering just messed up? Yeah. Okay, we should have a actual LSP now. Okay, and then we're gonna implement a draw method on both of these that takes eGUI UI and the project. And I don't know that these windows don't need any specific state yet. So I'm just gonna keep this like this, and we'll just write our UI in here. What? Not quite sure what's going on there. UI response? What is a UI response? Dang. Let's see how this is implemented Checkbox checked. Oh, they just return default. Can eGUI hook into Vulkan? I believe so. I believe it has an agnostic. It's similar to IMGUI in having like a agnostic renderer, or being render agnostic, I should say. By eGUI versus IMGUI. eGUI is just the Rust version of IMGUI. To my understanding, if you use IMGUI in Rust, you would just be using the C dir IMGUI bindings. Actually, both of them, to be precise, both of them are immediate mode GUIs, or IMGUI systems, so both of them are IMGUI. Just generally, when you refer to IMGUI, you mean dir IMGUI, which is the most popular. I believe it's C library? I believe it's C, not C++. They do have C++ bindings for, or helpers for like string and whatnot. But just, eGUI is Rust native. It's less mature, but it's Rust native. So we probably won't have an actual graph view here. What is widget text? Okay, you can just do an into. Now let's see what else we can mess around with. Because there's 32 method, only 2 of which are providable. So is tab closable? By default, we want this to be false. So by default, we're just going to make all tabs not closable. Closable. Plausible. Tab UI, drag UI. Detail pane. return false if a given plane should be removed from its parent. What is that supposed to mean? It's fun that there is a ton of color options. Though it is kind of weird that these are function calls instead of like get style for. I guess they would only be called once, so it's fine. Okay. So we have that. Let's get this rendering. So we'll pause our rendering of Snarl for now, and we'll say pub free. I'm actually going to keep this as not an import for now, just for... Where's the GUI tile? There it is. Just because tree could be one of our language concepts. I'm gonna say tree, and then editor pane behavior, I believe. See if I guessed correctly. I don't think they actually show they don't show in their example how to actually render it. So you do tree for the pane type. Is the behavior how we render it? So why did I define behavior? How do I render this? Let's see, create level documentation for full example. I don't see a full example, which is either a container or a pane. Each tile is identified by a random tile ID. Tile state is stored in a single tree, a struct which consists of a tiles and root tile ID. Behavior and look of the tree is controlled by the behavior trait. Now see, this would be pane. I'm going to actually rename this to editor pane. Editor pane. I'm in pain because editor. Okay, now to figure out how to construct a tree. Maybe you put the behavior in when you construct it. Oh, that's tile. We don't need tile, we need tree. Tree. Oh, there is a new implementation. Okay, so new, and then we're gonna say 0 root tile ID. Do I have to keep track of tile IDs myself? Oh, or this tile ID is the tile. That is the root tile ID. This contains all tiles. All tiles are on a flat layout. They're not in a tree. But we're constructing a tree. Got it. Okay. So we would do let tiles equal tiles. Is default. Let's look at. Oh wait, we're already in tiles. Okay, so we use insert. So if I insert a container with 2 tiles, which are 2 panes, yes, okay. So you're supposed to just use default for this? And this probably needs to be mutable. Insert horizontal tile, and then our children will be tile or vector insert pane or editor pane. First, the graph view. Actually, let's see. Yeah, this doesn't have a specific direction. It's just a indeed, the editor is in pane. Okay, and that should work as long as the bar checker isn't mad about nested mutable references. Tree, editor pane, new root, and then tiles. Actually, since I guess into doesn't work here because it's already EGUI ID non-zero non-zero U64. Okay. Can I do 0 since it's hashing it? I believe so. So now down here, we should be able to do self tree UI. Ah, and here's where you pass in the behavior. Hello, how goes it? Theoretically, we have UI panes now. If our build doesn't fail. I'm doing pretty good. Just refactoring UI again. So hopefully we can stop refactoring UI. Oh, have a borrow. No, we're being explicitly not perfectionist about UI right now. Because if I was being perfectionist about UI, then I would have stuck with the custom UI rendering system that I was working on. There it is. Why isn't this arrow? Why yellow? I guess it's because borrow moot is something that gets implicitly added in when we like use things like borrow them. And usually it's implicit. So it was a valid function call, it just didn't make sense. Even though it says no method named borrow mootably, so even that theory doesn't work. Not borrow tiles as mutable more than once at a time. Borrow checker, come on. Here's the thing. In my opinion, this borrow should not occur. Like, the scope of this borrow here is that if I add these in, that scopes the borrow. Or at least that should scope the borrow, but no, for some reason this is borrowed. And then we construct our arguments. When in my opinion, arguments should, like, the way that a language should work is arguments are implicitly evaluated before a function is called. Like, that's just how it works. And if you're doing a borrow checker system, they should also be out there. So but no, what I have to do is this, manually break them out, because the borrow checker can't tell that we don't have multiple mutable borrows happening at once. There we go. And that just works. That's exactly the way I wanted that to work. Wow. Maybe with some maybe some padding would be nice. But like, to start out, good. Okay. Now we need to add the graph back in. So the way we're gonna do that is make this a lifetime. And make this be references to everything we need. And then snarl mutable, snarl And now, instead of having this there, instead editor pane behavior equals project equals what? So now this structure just becomes like an immediate capture of state rather than a stateful thing that exists for longer, which I believe is how it was intended to be used. Yep. So it's essentially like passing a context in, but specifically a render time context. So any like per draw info we need to pass in, we can just do that here. Okay, so now that we have the reference to snarl passed in, I'm gonna delete Graph Viewer, because Graph Viewer I think is another one of these just create when you need it sort of deals. So here on Graph View, we're gonna do Graph Viewer default. Then self snarl. What was it? What was the name of the function? Oh, it's just tree UI? No. Snarl show, that was it. And we'll throw the style in there as well. Nice. And now we have an inspector bar over here and our graph over here, which is what I wanted. Delete that text. And let's make this window bigger by default. By 720 is like HD, right? Well, actually, it's not HD, it's standard. There we go. Do 1920 by 1080. There we go. Now it's by default the size we want it to be. Now can we resize this to specifically be like that big by default? Would this be part of tree? Ah, set width. There it is. And that's the exact width. Width used by the tree component. So this is the entire tree itself. Instead of... yeah. How do I... My nose is like super itchy right now. There. I want to resize one of my panes. Oh, there's a specific function call that we could use. Insert horizontal tile. now I need tree where it lets me insert. That would let me insert a container kind. Oh, I need to look at tiles, not tree. So I could insert container. Insert container, and then this would be a linear. Goes progress. It go. We currently progress is catching up to where I had it before. But yeah, progress actually goes fairly quickly at the moment. Oh, wait. We don't actually directly set shares. This is fraction, so I want to do 0. 9, I think? And then this can just be a slice. There we go. Let's change it to 8.5. That's a good default width. Nice. I am a fan of how this looks. Did we just burn through the entire mix? We did. Music change time. This was a good mix. Okay, so the next step is to make these nodes actually mean things. Now, here's something I've been thinking about, which is how should the layout of the actual graph itself work? Like, So we have a graph, and in that graph, you want your definitions of things. So let's say here is a function node, or a pipeline node, or something. This is a node that defines a compile time concept. Now, is this like a list of things over here on the left, or is it part of a graph itself? Random thought, I would love to be able to use a node scripting language where I don't have to constantly use my mouse and go back and forth with my keyboard. Ah, Vim bindings for node graph editor. I hear you. Since the way that I am currently thinking of is... So the way that I'm currently planning on storing the scripting language is in... Like, we serialize it to a text scripting language. So what you will see here will be the deserialized version of a regular scripting language. That's the end goal. But here's the thing. How do you store the positions of nodes in a text-based scripting system? The answer is you kind of don't want to. You like really don't want like random floating point variables and comments, or that metadata either goes elsewhere or you don't have it. And I don't want to have to store node position metadata. So what that ends up looking like is a node graph with a auto layout system, which means now that that's an auto layout system, what if I actually did just do Vim bindings for nodes or something similar to that, where you have bindings to like select this input, or like some way to select this input, and then you move your focused node over one down to, and then say connect to that input. Yeah, and control flow is just terrible in most scripting languages. One huge benefit of going the pure functional route is going to be you won't have to do control flow at all in the language. It will be, I think the proper term is, when it's compiling, it's lazily evaluated. Since there are no side effects, you basically go like, what data does this rely on? What data does this rely on? And there's no loops. There will be ways to do the same thing as loops, but it will be like iterators, transforming data rather than like actually defining a loop using nodes, because defining loops using nodes is terrible. And I might even have a for each node, but the way the node would work is there'd be a subgraph within the for each node. So the way that like a for each node would work is you'd like input values into the for each here, and then there would be a subgraph inside of the for each. And then here are your input values, and then maybe here's the current value of the for each. If you're iterating over like values, and then you do your transformations on data, and then you output the changed versions of that data, and then here you get all of your inputs, you then get them out of the outputs. So there's no weird like, here's my control flow arrow, and we go to this node, or on a branch we go over here, and then this arrow just like goes off into the nothingness, and then we have to remember, yes, when the loop repeats, this arrow is implicitly going back to here, and then it's continuing onward. No, we're not dealing with any of that mess. It's literally just all the loop data stuff happens in here, and you get your outputs from the loop data over here. And the same thing with if statements. The way that if statements are going to work is there's secretly going to be a match statement, but here is condition 1, here is condition 2, inputs here, and you get all your inputs here. So if, say, this condition here is true or false, if it's true, we run this graph here. If it's false, we run this graph here. And then you get the same outputs from both branches. So the rest of your node graph doesn't have to worry about what happened in the if statement. It just deals with it, because it sees the same values output from the, or rather, it doesn't have to deal with it because it sees the same values output from that if statement. And then you can take that further and do like a Rust style match statement, which is why I said that the if statement was secretly a match statement, because an if statement is just a match on a Boolean. So you could have like the equivalent of a switch statement or a match statement where you have multiple different subgraphs for each value in here. And then, of course, same output values when you're done with that. So that's how that is going to work. Now I'm thinking, how do we define the top level concepts? How do we define a function? How do we define a pipeline? And I'm also thinking about how I want to do macros, because I do want to have macros. I do want to have the ability to do some form of compile time computation. And the way that I'm thinking about that is it'd be really cool if we just had this is like an extreme hot take of mine, but I am a fan of the C++ template system. Now, there are a lot of flaws with it, but the idea of being able to use the type info, not type info, I'm thinking of, what's the name of that one header? It's been a hot minute since I've consistently used, it is the type info header. Or is it? What is the name of that header? Not type info. C++ is type function. This will give me the right location. Oh, is it just metaprogramming? There it is. This is one of my favorite parts of C++, is metaprogramming. I spent so much time metaprogramming. Now, I do also really like Rust's macros, where they're just like, yeah, you can just run code at compile time. But I also really like just pairing metaprogramming with C++ const expression. I can just say, hey, I want this code to run in the compiler, and it lives in the same binary. Like, I can put a macro or a constant expression right next to my other code, and then just like it just works. Like, I don't have to create another library specifically just for all of my macros. I don't have to learn like a weird metaprogramming macro. Like, C++ templates are super easy to use. think C++ metaprogramming is more powerful than Rust typical code. So Rust macros are the most powerful macro you could possibly do, because there is the type of macros that you can just define in your crates, and that's using like a Rust macro rules. So there's this. You can throw this syntax into your function, and this is the equivalent of a C++ define or C define preprocessor macro. That's essentially what this is. And then, yeah, this is like the equivalent of the C++ processor, but if you do a proc macro, what you get is a raw token stream. So this is like fresh out of the parser. You just get the syntax of the language, and then you can write regular Rust code to edit the syntax of the language to be whatever you want it to be. The only barrier on that is there's certain things, they're called groups. So anytime you have delimiters like curly braces or parentheses or brackets, you aren't able to make pairs of those that don't match. Those always need to like have a match and then tokens inside of them or not tokens inside of them. But aside from that, you can take any syntax you want and turn it into whatever syntax you want using generic Rust code. So this could go, you can make a REST API and call a REST API from Rust derived macros. Like that's something you can do, is make database calls from your Rust macros. Now, what you can't do in a Rust macro, you can't check what types are. What you would use for doing any of this is the traits system in Rust. So macros and traits don't mix. That's not something you can do. Now, I don't want to have two separate systems. I want to be able to use code to define code. That is something that I want to be able to do. Now, using code to just straight up write code, that's something that currently, this is like super useful in a lot of ways, but it's not the usual usage that you need for macros. This is like the primary use that I've needed this for is when I'm writing bindings between this language and other languages. Like if I need a ton of boilerplate, I can just throw it into a macro. Circle programming language, metaprogramming. I will look that up in a second. But kind of finishing my point here is I would really love for this graph scripting system to support constant expression based metaprogramming. So everything in the language is the language is described through constant expressions. So if you think of a Python program, the way a Python programming works is when you load a Py file into the interpreter, it just runs everything in that file. So when you define a library, it's not like you reference the functions in the library. No, it's you run that library file, and then running that file defines all the functions. Now, I hate Python in a lot of ways. hate a lot of things about Python. I still use it for utility scripts. It is a great language for making utility scripts. But I do like the... What if you could... The way that you defined programs was... It would run at compile time. There'd be compile time code that runs to define all these functions. So like when I say struct app UI here, instead of this being like a in the ether there's a struct that is being defined, instead this is a compile time struct creation call. And that way I would be able to do a if compile definition and just do that, and then our struct is defined, and you would then use the exact same syntax for everything else. You'd use the exact same syntax for constant expressions as you would for the rest of the program, just kind of interleaving it. Now, you would be able to expressly define that things have the constant expression trait. Or that they, like, are constant expressions. So there would be syntax that you could write to say, hey, make sure that this, and when I say like if statement there, I do mean like if statement in the graph, but there would be ways to like explicitly say like, make sure that this is a constant expression, like this is compile time evaluated. And I believe I would also do like color coding on the node graph itself. Yeah, Rust does have, like, they currently have a proposal out for, if you use the experimental toolchain, the nightly toolchain, you are able to make a trait definitions conditional on their inputs. So they do have the start of metaprogramming happening, but not quite enough yet. Like, it's really hard to define a function and then define it for only certain types conditionally. Like, I can't do like a generic template definition or a generic trait function definition that acts differently based on different traits. I can do one singular generic implementation, and then no differences. But it'd be really cool to just do like a compile time if statement that's like, if t has trait foo, if t has trait foo, do this path. If t has trait other trait, do this other path. Like, I could do so many cool things with that. And that's how I wanted to work within functions. But it would also be interesting to see, like, on the greater graph scale. Now, the one danger with that is, with the pure functional route that I'm currently taking, what that would look like is you'd have, this is the entirety of one graph, or one compile unit, let's say. I think I called them groups. So here is our group definition. Actually, this is a group definition here. This is a group definition, and now suddenly, if I want to have this have compile time behavior for defining all of our functions inside of this group, then what that looks like is you have an entry point Actually, no, you wouldn't have an entry point, because we don't care about control flow. Pure functional, no control flow. No explicit ordering of operations. No control operator. There is control flow, but not... I guess it would be data flow, not control flow. But essentially, you would have one output node here, which is your definitions for this group. So you would have this function here, and yeah. Now, the problem is, how do I make self-referencing definitions with this system? The answer is, you can't. You can't make self-referencing definitions with this system, if you explicitly have to draw these lines everywhere. I could have, like, a self node. When we're defining types, I could have a self node. So a function... If we define a function, and this function needs to call itself, we could recursively call the self node. And this also, if we have the explicit, like, a function can't call itself, but it can call a node called self, which has the same exact definitions that it does. That means... I guess we would have one input here, which is our compile flags. Question is, would the function... I guess a function node would take in an argument of... You take in an input of name. You take in an input of arguments. Also take in an input of, like, outputs. So there are inputs to this function node, meaning that inputs are already defined at this point, meaning we can statically validate the self inputs and outputs. I guess that, honestly, that's a fine or perfectly valid abstraction. Though now the other concern I have is, how does this function reference other defined nodes, other defined function nodes in this graph? Like, if this function needs to call other functions in the graph, would we then need to pass this called function into, like, just directly into that function? Or would we be able to implicitly do that? Or because the entire point of this language is very explicit control of data flow. And I guess we're extending that to the compiler side as well at this point. But do I want to extend that to the compiler side? Here I could have constant expression inputs to the function. We then pass into the graph. And that way we could have a graph of, like, here's our compile definitions, and there's also conditional definitions. Like, you would need to match on the current, you would need to check the current compile definitions to see if, say, self, or, yeah, if you're importing other graphs, or other groups, if we import other groups, and those groups have compile definitions, we would need to check compile definitions in this graph before being able to reference functions from that graph. See, this is all, I feel like that would kill the language if I did enforce the need to do all of that explicitly. Aside from the basic, like, if compile definition, define this, or define this, depending on compile definition. But when it comes to greater, when it comes to anything larger than that, I feel like having to explicitly pass all the functions you're going to call into a group, I feel like that would be far too verbose for this. So even if that's how it works behind the scenes, it needs to be implicit to some level. I do really like the idea of defining things within a group itself to just be another graph, but with a function is a compile time expression. See, here's the thing. Since this is a language running in a runtime, a function doesn't necessarily have to be a compile time thing. I could JIT compile functions at runtime. That is a thing I could do, and it's a thing I also want to do, to be honest, is the ability to have the coding language be able to literally code itself. Like, that would be really cool. Fully JIT compiled code generation, like the ability to generate code from the language itself. I do want like a very well-defined API for having editor tools be able to emit scripts. Like, I want the animation system to essentially be another abstraction over the scripting language. That way you can, like, you would be able to statically verify animation events, for instance, if that was something you did. Like, this animation must have this event, it must have this event defined somewhere in the animation. And then you're able to statically compile that, or statically verify that. Like, that would be really cool. But that's getting a little bit ahead of myself. I think for now, we just say yes. Functions are nodes in the graph, in a graph, and they all need to be connected to a definitions output. Compile time vector of outputs. Yeah. For now, we'll just have it be like a single def output, but eventually I want it to be explicitly or implicitly we're creating a vector of functions and then passing that out. For now, we can just we can do one output. All right, I'm gonna go take care of something and then be right back. Yes, I know my right touch controller battery, so yes, I'm aware of that. Oh, that's why this is so unwieldy. It's because I have the feet, like, flatly splayed out, instead of... There we go, I'll actually be able to position that now. Anyway. Alright, we are back and losing controllers. Looks like really red on the preview. Is that what color that is? Oh, you just white balance adjusted. Yeah, but it did look really red. Oh, cool. I don't even have to reset it. Nice. No, my cursor is bugged. Oh, wait. Is it because it thinks that I have a controller pointing at the screen? Where's my right controller? Yeah. Let's link. Oh, this is Steam. Right. I'm not in Quest Link right now, I'm in Steam. There we go, I can see my cursor again. Nice. Okay. So, with that realization of like, I definitely want this to start moving towards this way, and then we can experiment with how to actually make it that not terrible to use. How do we make devs not hate us? Challenge level impossible. See, there's a level of dislike that is acceptable, and then there's a level of dislike that we can't deal with. Ooh. I just realized something. And the thing that I realized is... for this to work, potentially, but no, for this to work, we essentially have to create a tiny interpreter. Because if definitions are graph-based, like if there's actual compile time execution happening here, that means we need to write tiny interpreter. And then the interpreter returns the actual definitions of things. And then we need to cache those for our LSP to work with them. Which is a complete restructuring of the way it currently works. Oh man, I'm just... I am soft for recreating the way that, like, dynamically typed languages work right now. On my screen, it still says you're in the number 1 spot. So it's bugged. See, like, you're fine. You're leagues above. Does this mean I have to make a Brane script interpreter? And then interpret. And also, do I want to go as far as having compile units? Because we could make a we could make a hierarchy of compile units, like a dependency graph. But then you do have the issue of, like, what if you have... Oh no, what if I have a circular dependency graph? There's no way in our current functional paradigm to handle this. And my link is, like, slightly... Maybe it's just Steam's overlay? I'm not sure. Might be Steam's overlay. Okay, we're back. Yeah, so I don't think we go as far as... I don't think we go as far as making, whatchamacallit, it's making dependency graphs their own interpreter thing. At least for now. That might be part of Brane Engine. But actually, would we? Okay, here's a graph. We have this function here, and it has this runtime here. Like, this is the definition of the function. And then we also have another function, bar. With this definition here. And what if foo calls bar? Now you may think like, oh, we need to pass in a reference here, a bar, but I have an idea. What if the interior of these functions is not evaluated until the entire graph is also evaluated? So after the entire graph is evaluated, then we evaluate these scopes and we pass in a reference to the context at which, or to the graph they were created within. Yeah. And then that completely circumvents the need to directly pass functions in, because we can just say, hey, the defined like context of functions is just implicit. It's implicit. We don't need to actually pass in functions as first class values because they already implicitly exist. Like, we're implicitly creating a graph where we import them. Okay, so compiler becomes a simple VM for now. The VM executes node definition graphs. Top level compile units are top-level compile units are compile time graphs. So it's enforced that everything they execute is at compile time. Sub graphs are only resolved after their parents are fully resolved. See, and then subgraphs may reference okay, yeah. Subgraphs may implicitly reference compile time values defined so in this case functions are compile time just constant expressions. So this would be the equivalent of me going const foo is function is equal to like that. This is just a compile time. This is literally a constant. This is a function definition, but it's defined as if it is a value. So by doing that, we can just implicitly say that this is how this works. compile units are just a compile time